Carbonova is a new technology that turns carbon dioxide emissions into high-grade carbon nanofibers for industrial usage. Green products from greenhouse gases. A technology company called Carbonova is working on a method to create superior carbon nanofibers in large quantities, Carbonova fiber, for use in broad commercial applications. The Carbonova technology uses enormous amounts of greenhouse gas feedstocks each year, converting them into a stable, long-lasting, and lucrative commodity. The proprietary technique and catalyst formulation belong to the company. Carbonova, which has its corporate headquarters in Alberta, is on track to build the first significant commercial carbon nanofibers facility in Canada. Methane and carbon dioxide, two greenhouse gases, are fed into a chamber the size and shape of a wasp's nest through lines coming from a number of tanks. The more precious carbon fiber at the other end, which is used to make golf clubs, cars, and other useful items, soon spews forth. The product's material known as carbon nanofiber has exceptional mechanical, thermal, electrical, and chemical capabilities. Tires, electronics, textiles, ink, coatings, concrete, electronics, transportation vehicles, and agriculture are just a few of the products that use it. They employed a novel technique that produces carbon nanofibers using methane and carbon dioxide. The raw materials are cheap and have a big impact on global warming. They get turned into something precious and in high demand. The main differences of Carbonova technology: valuable and in high demand carbon nanofiber is 4 times lighter and 40 times stronger than steel. Furthermore, it created a completely new class of super ultra high strength, allowing us to push the limits of what we believe is possible. Do you want an elevator to space? Reduced energy prices and demand. The Carbonova cycle recycles and recovers excess heat while using a unique catalyst surface chemistry. As a result, the production of carbon nanofibers from carbon dioxide is sped up while requiring less energy. The high cost of raw materials and the high energy requirements, which are the main cost drivers in most production, are both solved by their process. Utilizes greenhouse gases. Greenhouse gas emissions are the main culprit for most industries. Greenhouse gases are transformed into valuable products with Carbonova technology that can be scaled up globally soon. Greenhouse gases are used as raw materials to make new materials and products that are high quality and very useful. If most of the emission gases are turned into products, there won't be any global warming from emissions much longer. Extremely scalable. Not only can their special technique change carbon dioxide, but it can also change methane, which has a 30 times greater influence on global warming. Capturing methane into carbon nanofibers opens the way to further recycling of greenhouse gases from landfills, biomass, and natural gas reservoirs with high carbon dioxide concentrations. Each year, about 140 billion cubic meters of methane are released into the atmosphere. The Carbonova technology performs in a continuous flow mode with a high rate of conversion, which is similar to conventional catalytic processes in many ways. Other methods like plasma, laser, and electrochemical processes do not have its problems or restrictions. Applications for Carbonova fibers. Carbon nanofibers have limitless potential, and more applications will be found as we advance farther into the future. Displacement of metal polymers with Carbonova fiber reinforcement. With improved mechanical, thermal, and electrical qualities, carbon fiber reinforced polymers, CFRP, are replacing metals, steel and aluminum in numerous applications. Tire, rubber, and elastomers. Rubber reinforced with Carbonova fiber for improved traction in tire manufacturing. Carbon nanofibers boost rolling resistance, abrasion resistance, and wet grip. Lubricants. Oil and water-based fluid lubricants with Carbonova fiber modifications. Carbonova nanofibers improve wear resistance and minimize friction coefficient. Carbon nanofibers also offer good thermal dissipation and electrical conductivities for well logging applications, and they are safe in the harsh thermal and chemical environment. Electronic devices. Capacitors and batteries made of Carbonova fiber. Because of their excellent electrical conductivity, carbon fibers are being utilized in electronic components like batteries, capacitors, and transistors. Coatings and inks. Coatings made with Carbonova fiber. Coatings' tensile strength and wear resistance are improved by carbon nanofibers. Additionally, they give the coating a conductive network and reduce the need for sacrificial metal for corrosion control. Coatings. Agriculture. Micronutrients from Carbonova fiber. In agriculture, carbon nanofibers can absorb and store various other substances thanks to their large surface area. They have the capacity to absorb vital micronutrients and release them gradually into the soil.